Okay, so I'm recording. And like I said, networks are all around us. Okay, and we want to see how we can actually take advantage of the whole concept of networks and then represent it in GIS. Okay, so you see my PowerPoint. You can see that we can have road networks. Exactly. We can have rail networks. We can have cable network. You can have pipeline network. You can have streams and even glaciers. Are you okay? Now the
So
common
please, is
thing.
it types of networks?
Sorry.
Is it types of networks? The road, the railways, cables, pipeline. Is it types of networks analysis, or is it types of network, or is the medium which networks are passed through?
Okay, let me carry on. You understand it better.
Okay.
As we go, you understand as we go. Okay.
Okay, sir.
I'm just making a point. So let me finish. All right. So roads and the railways, cables have something in common. The commonality. What is the common thing amongst these things are that you have something moving along. Are you okay? You have resources. For roads, you have a car moving from one point to the other. But if you had one road through a certain country, what would it mean? Isaiah, can you imagine if you had one road moving from Accra to Tamale, and that was the only road? What would be the disadvantage of doing that? That means that you cannot.
There will be traffic. There will be traffic. High traffic.
There will be a lot of traffic, yeah, and eventually you won't be able to move anything at all.
Yes.
And you can see that is not a network. So the basic network will be just one single link. One single link. That was the basic, one single link. So there's a beginning and there's the end of the link. Is okay. In fact, you can actually call this the node, the beginning node and the end node, as we talked about in topology. Is okay. So in topology, we had a from node and a to node. The same thing is happening here, right? So the connection between the links are possible because we have the nodes at the end of the lines or the arcs. So another name for a link is a segment. Another name for it is an edge. Is okay. So there are about three names we can give to a link, a road link. Okay. So between one node and the other, you can have a link.
Museum. Music to enjoy life.
Link. You can have an edge. Have a segment. So all these are actually meaning the same things. They are like the line between two nodes, the link between two nodes. It's all right. So when you look at a road, we have this interconnectivity between edges. All right. So let me just go back to I think I have a whiteboard. Where's the whiteboard? Well, let me start one. Okay, there is a whiteboard. Let me share my whiteboard. Okay. Okay, that's because I'm not doing this. Okay, great. So this is what I'm saying. If you hear me out, that if you had just one road going through a town, okay, so it is a town, then you couldn't possibly reach all these other parts because there's no, you can't reach it. So the whole idea is to now branch off. Okay, so you can branch off at any point. All right, this is reality. This is reality. This is the real world. It's all right. Now, if you want to actually represent this in GIS, I mean, of course, in the vector model, we can represent this by lines. Okay. All right. Now, the vector model, there is a certain variant of the vector model, which is actually the topological model. The topological model, then you can see that truly there's no join. If someone has a mic on and is disturbing me, they should turn it off. Is that okay? All right, I've turned it off. It's a lot of wind blowing where you are. So here we have a better representation. It's assumed that the round objects are the nodes. Okay, so here we are linking topology. Okay, we are linking topology and then networks. We're talking about the elements of a network that it has segments, and these segments are connecting. It has lines. These lines are connecting at only nodes. That's topology. Are you okay? Okay. So these are the segments that you have. That's a segment. That's another one. That's another segment. All right. Okay. So this is the representation of the T-junction that we have up there. So this diagram versus this diagram, one of them is the real on the ground. When you get out of your house and you are moving from one point to the other, you'll be driving your car on the road that looks like this. The one on top, that's real. And then down there, you have the representation using the topological concepts. Are you okay? Like connectivity is all right. Great. So let's go back to networks. I want you to think about networks like this. And so with a pipe network, you are looking at the same thing, but with a pipe network, you have the pipes being the segments or the edges of the network. Whilst for a road, you have a road section, okay, where there's no junction, there's no T-junction, there's no crossroad, then you have just that. So it depends on the kind of network that you are looking at in real world. Is okay. All right, but they are all sharing one thing. So they are all networks, but just that their implementation is different. In other words, you can have an electrical network. In fact, when you do electrical engineering, electronic engineering, electronic engineering, you have a way of solving for the current within the network. Are you okay? And you can use what we call catch-ups to do it. Are you okay? And there are different methods of doing that. Okay, even in the electrical networks, you still have that interconnectivity, and we have nodes. Is that okay? So you could have, capacitors, resistors being at, certain points of it. You don't have that a lot. In roads, whether you are in a straight section or you are at a junction, so the electrical networks a bit different in terms of the introduction of even the resistance, and the capacitors are actually impedances on the network. They are impedances on the network. So a road with a lot of potholes, the potholes now become an impedance. A road with a reduced speed limit so that you can't travel above 50 kilometers, that becomes an impedance. you can that stops you from traveling. A road which is just too long is also another impedance. So distance itself can become an impedance. So what am I talking about? I'm talking about a network. The parts of it which are the link, the nodes, and then the attributes of the links typically are for a road network speed limits. It could be the class of road can be an impedance. If you're traveling on a road which is class D or class C or whatever, you can't drive as fast as you drive. So these are the realities of networks around us. Same as railway, there's always going to be, the actual train that moves on the rail. Are you okay? So the rail is the actual link. Are you okay? In real life. So we have streams. Yeah, have one stream. All streams lead to the sea. People say that all the time. All rivers flow to the sea and all that. But then we all know we have tributaries. There are points where the rivers, the lakes, lakes are still, but streams do split up. Okay, are tributaries. And at that point, you have a stream network. I mean, if you look at actually all the streams and hydrology in Ghana, you realize that the streams are just like roads. They split up at a point. One stream kind of branches and it starts another one, and then they keep going, of course, because there's a linkage between the underground water and then the water that flows on top, depending on the type of soil, bedrock, etc. that you have. Okay, so networks are interesting. They are used to move people. They are used to transport goods. They communicate information. Networks, talking about making a call. So when you take your phone right now, in fact, what we are doing right now, it's a network we are all making use of. All right. We are making use of the Zoom server, which means that all our communication right now, everyone who is logged on to Zoom now is making use of one node in that network, in that network that we want to call the internet. Are you okay? We need to understand what these things are in real life, and then to see the connection with their representation in GIS. So GIS, I told you when we started, I told about GIS. GIS is really about everything. That is what makes GIS interesting and special. It's really about everything that we see around us. The control and flow of matter and energy. Yeah. Once you got something moving, water is moving from one point to the other through a certain conduit or channel, then you got to share it, isn't it? Then networks coming. All right. Because the same water that's released by Ghana Water Company, it gets to your house, gets to everybody's house, because we are having a certain network of pipes of different diameters, dimensions, and lengths. Okay. All right. I don't know if as a class we touched on attributes. I think we have. Most of you say we haven't, but we have. So then the attributes of a network determine the effectiveness of it. Is that okay? This statement I made, I'll repeat it again. Obviously, we can look at this one is a drainage network. In class, I asked you to give examples on the use of lines to represent in the vector model and real life and examples. And we talked about drainage network. And I remember I was talking about it really passionately, isn't it? About the fact that we don't have a drainage network in Ghana. Okay, we don't have a drainage network in Ghana. We do have segments and pieces, okay, of what we call drains. Is that okay? But they are not networked. Are you understanding what I'm saying? I hope you are, and I hope you are following. Okay. So we do have to understand the whole idea of the network. And when we understand it, we will know that a lot of things are wrong around us. We will figure out very soon. Here on the right hand side, you see the London Underground. Okay. Now, if I'm to zoom closer, which I don't know how far I can go with it, you see white round circles. Some are merged, some are single. All right. These
we cannot see.
Oh, you can't. Sorry. I think I'm showing you the wrong thing. Great. So the underground network, rail network in London looks like this. The circles are supposed to be junctions. Is that okay? It's supposed to be junctions. So there are places where you can change and move in a different direction. So the possibility of reaching places are diverse. In other words, if you feel one route or route is not helping you, use the other. And you have the freedom to do that, to make that change. Obviously, I'm not really teaching about how it works, but that is the idea of a network. The idea of network is that the resource, the good, the energy is supposed to move from one point and freely to get to the other points. Okay, we take advantage of that to create the internet, which is a very huge worldwide network. Are you with me? All right. So this is a real network which we can relate to in Ghana, because we have just done one real network going from one point to the other. It's like, I mean, if someone wants to actually catch you escaping via a real network, I mean, like, it's like just go and wait at a Cramo and there the guy is, he's gone. But not on such a network. It's going to be very difficult. The possibilities are just so many. Are you okay? You can change, because so if you're tracking someone from one point on this network, are you okay, to the other, let me get this too. If someone is here, okay, and you're interested in getting, you don't even know which direction they are going to go. They can decide to go in any direction. They could be standing on the left or the right side of the platform. Okay, so on a rail, there's always what we call the platform. They could just go in 4 directions, and you don't have any clue. If they decide to go and even show, you never know where they may just change again, because there are so many of these nodes at which the lines are connectivity. The questions you get in exam sound like this. So I have to make the lecture like that. It has to be practical. If it has to be practical, the lecture has to also be practical. So try and relate, but don't lose track of the main concept, which is arcs meeting and nodes. In fact, topology is networks in disguise. We talk about topology. The connectivity rule is actually linking directly with network analysis, which we are talking about. Okay, so the Zoom session will end soon and we'll reconnect again and continue. But I want you to understand one thing, that if we implemented a proper, for example, drainage network in Ghana, we wouldn't have to struggle a lot with a lot of the problems that we're having with flooding and the stench that meets you, that emanates in our neighborhoods. But anyway, I'm getting emotional here. So obviously, networks are all around us. Is that okay? And but then someone asks you, is this a network? What would be the criteria for analyzing, evaluating that you are really looking at a network? We're talking about power lines here. Are you okay? So you see a stream, a part of a stream up there. We have gas pipelines. Okay. So how do you get gas into your house? I when I was in the UK, stayed there for some months, and some years I was there. You never see anybody carrying a gas cylinder, to go and buy gas. Question that you should ask yourself: where is the gas coming from? Literally means you could blow up the whole house. You understand that? So some of the things that we're watching in the videos and all that, it should prompt us to think about our own like development. I'm getting emotional here. All right. So power lines, light voltage poles versus like heavy voltage. I don't know. Are you okay? So low voltage, high voltage, yeah. Low voltage, not light voltage, low voltage, high voltage. They are on separate networks, but there's a hierarchy. Are you okay? It's a hierarchy. So the power going through the high tension pylons is not the same voltage. In fact, they are not on the same network with the one that is going in front of your house. They are on different networks, but they are in a different hierarchy. So that can be a property of the algorithm, a parameter that can be set in the program for determining like which part of the network we need to look at in terms of maintenance, whatever it is. So we're going to talk more about this, and then we move into surface analysis. So let's rejoin. I think the time is up for this Zoom session.